Another day, another dollar. Asambe sobabona. Tip bezwayo. Zonke. Bonke. Bonke. Okay, guys. Oh, thank you. Thank you so much. Thank you for your attendance. Thank you for your efforts that you have made to watch this video. And this will be part 11. Part 11 of our exponents and surds. Okay, exponents and surds Okay, so this is part 11 of exponents and surds. And then quickly, without any waste of time, guys, let us just take an example. Okay, wait, I'm sorry, forgot to give you the subtopic, guys. So our subtopic, it is equations with rational exponents. We spoke about this before. If your memory it's still good, you know that we spoke about rational exponents. Okay, so our subtopic, it is equations with rational exponents. Thank you. Equations with rational exponents. Okay, so quickly let us take an example without any waste of time. I'm sorry about that, guys. Let us take example 15. Okay, example 15. Example 15. Okay, so here we have x exponent 1 over 2. It's equals to 4. Okay, so there are two ways where you can solve this. Okay, so the first part, you know that it is my preaching that always whenever you are dealing with exponents, make sure that your bases are in prime number form. Okay, and then we know that we just wanna strip off this x so that there is no any impurity that is attached to this x. Okay, that's how we solve x. Okay, so solving x, guys, it's all about making sure that there's nothing attached to this x, and then x is on its own side. Okay, it is on its own side. Okay, so how can we remove this 1 over 2 because of this exponent 1 over 2? It is the impurity that we want to remove. Okay, so you simply multiply by its reciprocal, which is 2 over 1. Okay, then laws of equations says that whatever that you do on left, you must also do on the right. Okay, so 2 will go away with 2, and then this side you will remain with x, and then on your right hand side you are simply going to remain with 2 exponent 4. And then I told you guys that you must make sure that when you have answered a question based on exponents, try to make sure that your answer are not in exponents form. Okay, try to simplify it as far as you can, as much as possible. Okay, so 2 exponent 4, what is it, guys? 2 exponent 4, it is 16, right? So the alternative that you could have used, it is this one. So simply from here, from that step, you can simply change that and then say that x exponent 1 over 2, it is the same as x square root x, remember, and then it is the same as 4. Okay, then now you just want to remove this root sign from this x so that x can be left alone, can remain naked. Okay, we are stripping off any impurities. So how do you remove that square root on that x? You square it like that, and then whatever that you do on left hand side, that also must be done on the left hand side, then eventually x becomes 16 like that. Because of this, we'll go away with it. Okay. Another example quickly. Let us consider this one, x exponent 1 over 3, it is equals to 3. How are you going to approach this one? Same approach. Okay, so simply you're going to say x exponent 1 over 3 times its reciprocal, which is 3 over 1. It's equals to 3 exponent 3 over 1 or 3 over 1. Remember, it is the same as 3, so I just said 3. Okay, then from here this 3 will cancel the 3, the 1 will go away with 1, and your x will be 3 exponent 3, it is 27. Simple as that. Okay, or you could have took this root, that 3 will be there. Okay, x exponent 1 over 3, it is the same as the cube root of x. We have done this in the previous videos. Make sure that you go and watch them. Then 3. Okay, then what do you do from here? How do you remove this cube root? So cube root, it's simply removed by cubing whatever that you will be having. Whatever that you do on the left must also be done on the right. Okay, so this will go away with the cube root, then you remain with 3. It's equals to this is x, guys, sorry. So you remain with x, it's equals to 27. Math is so beautiful, guys. I enjoy doing this. Okay, so now let us do something. Okay, allow me, guys, to use the red one. Okay, because of this is of importance, guys. Please do pay attention and listen to me very careful. Okay, so if ever you are having x exponent 1 over 2, okay, so guys, remember we are talking about rational exponents. Okay, so rational exponents, guys, do not work. Okay, let me not say that they do not work. Let me say that a rational exponent of an even denominator, you see my 2 is even denominator, will never give you a negative answer. Okay, so rational exponents with even denominator will never ever give you a negative answer. Okay, so once you have a rational exponent like this and then your denominator is even, know that there can never be minus that side. It's impossible, guys. It is impossible. Okay, but then what's possible? What's possible is that if we had a rational exponent with an odd denominator, this is highly possible. It's doable. Okay, but then this one, it is not doable. I hope you get this, guys. So this is how you see them. You just check your your denominator's exponent. So if it's even, just know that you will never ever get a negative answer, no matter which even number you can put there. But then if ever it's odd like that, remember, hey, you know, I'm busy saying even and odd, and you might find that people do not know what is even and odd. Okay, so when I'm talking about odd, I'm talking about 1, 3, 5, and so on. And then even, I'm talking about 2, 4, 6. Okay, so cool. Then this one, guys, it cannot work. Okay, we had it in our book. Yeah, it's not doable. Okay, even on your calculator, it's gonna give you a math error. Okay, so let me just make a small note for you, something for you to note. Okay, so note this, guys. Note, if you have x 1 over even number there, it can never be negative number. Okay, so this statement, guys, it is very powerful. Make sure that you do not forget it. Okay, guys, I hope you see this. Yeah, make sure that you remember it. because of it will help you so much, guys. Okay, yes, let's continue, guys. Let's do example 16 quickly. Let me change the color of my pen. This red, guys, it is for those ones that you really need to know and not forget. Okay, so quickly we are doing example 16. Example 16. Okay, example 16. So under example 16 we have solve for x. Solve for x. Okay, so what are we solving, guys? The first one, we have x exponent 1 over 4. It is equals to 3. Okay, how are you going to deal with this one? Easy, guys. Easy things. 1 over 4. We multiply it by its reciprocal, which is the same. Remember, 4 over 1, it is the same as 4, guys. So I'm just doing 4 over 1 because of sometimes learners ask me, why are you not using 4 over 1? Okay, but then 4 over 1, it is the same as 4. So whatever that we multiplied with on the left must also be done on the right. Okay, and from there, x is equals to this. 4 will go away with that 4, and then that one with that one, and then 3 exponent 4. What is it, guys? What is 3 exponent 4? Whatever it is, guys, it is 81. Okay, so let's do the second one, guys. Okay, so now x exponent 1 over 4, it is equals to -3. Remember what I just said earlier, guys. I said that if ever you are dealing with rational exponents and your denominator it is even, you will never ever get a negative number. So this thing, guys, doesn't exist. Okay, you can say no solution. No solution. And then what will be the reason? Even denominator. Okay, even denom. Guys, I can't write the full denominator there. Okay, then let us take x exponent 1 over 3. Okay, x exponent 1 over 3. See, x exponent 1 over 3, it's equals to -3. This one, it is surely doable. Okay, so we are going to say that x exponent 1 over 3 multiplied by its reciprocal 3, it's equals to -3. So be careful, guys. Respect the negative values. Okay, be careful of them. Always, whatever that you do into them, guys, you must put them in the brackets. Otherwise, you will see flames. It will deal with you. Okay, so whatever that you do to negative values, put them in the brackets. So you see this -3, I had put it in the brackets. Okay, so 3 will cancel 3, guys, and x will remain there, and then -3 cube, it is the same as 27. You can just press your calculator and you will definitely get this answer that I am talking about. Okay, of course there are other alternatives, guys, but then I can't keep on showing you alternatives everywhere. So x exponent 1 over 3, it is the same as cube root of x. Okay, and then cube root of x exponent -3. So you know that the cube root of x, how do you remove the cube root? You simply cube it. Okay, take the cube root of this thing. I mean, you take the cube of this thing. So this 3 will go away with it, and then you will remain with -3 cube there, and your answer for x will be 27, like the one that we just got earlier on. Okay, all right. So guys, of course, there is a proposal in your book on how they do the following. Okay, whatever that I'm going to do now, there is a certain way that they do it, but then now I'm just going to do it the way I know it. Okay, but then you can follow the method, or preference, you can just go and hear your teacher, what your teacher prefers. Okay, guys. So, but then now let us take this and then check how is it different from the ones that we have already done. Okay, let's say that you have x exponent 2 over 3, it is equals to 4. Okay, how is this different, guys, from the ones that we've been doing? Of course, the difference is this part. On the previous one, here we had our numerator being 1, and then now it's 2. All of them, they were 1, but then now it's 2. Okay, then how do I approach this? Not a big deal. So I simply multiply by its reciprocal. Okay, like that. And then you say that for it is for whatever that you did this side, it must also be done in this side. So it means even this side you should have multiplied by its reciprocal. Okay, then this will go away with that, this will go away with that. Then your x will be 4 exponent 3 over 2. Okay, so for exponent 3 over 2, it is the same as the root of 4 cube. Okay, and the root of 4 cube, guys, it is the same as the root of, what is 4 cube, guys? 4 cube, am I doing the right thing here? Okay, yes, I am doing the right thing. So 4 cube, guys, it is 64 if I'm not wrong. And then now the root of 64, it is what? It is plus minus what? Plus minus 8. Okay, so this is one of the things, guys, that I will emphasize to you. Every answer, when it is out of the square root, it comes out with plus and minus. Okay, plus minus 8. Okay, so every answer, guys, when it comes out of the square root, it comes out with plus minus 8. Okay, so then you can conclude that your x is equals to 8, or your x is equals to minus 8, like that. Okay, let me just check the top ones. So here you see, guys, it was a cube root. So a cube root, it just comes straight like that. Yeah, but then that one, guys, this is how to do it. Let me check the cube root. Let me check the square root. Okay, so yeah, every number that comes out of the square root, guys, it comes out as plus minus that number. Okay, I hope I'm ahead. Okay, guys, let's take another one, which might be a bit challenging. These other ones, guys, I will jump them. B, C, I will jump it. Let me try the negative one. Okay, let me try x exponent 2 over 3. It's equals to minus 4. X exponent 2 over 3, it is equals to minus 4. Okay, then how do you deal with this one? Then you can simply change thing to be a root sign. Okay, the thing there, yes, you can change it to be a root sign, or you can just say that x is equals to 2 over 3 multiplied by its reciprocal 3 over 2, it's equals to minus 4. Like, you know, guys, how much I have respect for negative numbers. That's why you will always see that whenever I do something in them, I put them in a cage. Okay, so x is equals to this will cancel with that will cancel with that. Okay, cross cancellation. Then now on this one, we can change this to be the root of minus 4 cube, like that. Okay, so guys, the basics are very important. So you will understand how do we change our rational exponents to root sign. It is the previous chapters. Okay, so x, it is equals to, now what's gonna happen here is that the cube root of minus 4, it is the negative number. And then what is it, guys? The cube root of minus 4. The cube root of minus 4, I don't have a calculator with me here, but then you just press it and then it will give you a negative number. Okay, and then we know that it is impossible. Why? Because of we don't have the root signs no roots, no even roots actually. Remember here it's even, so no even roots with negative numbers. With negative numbers. Okay, so let me make an emphasis again on this one, guys. So every time, guys, when you root even roots, let me write it like this. Let me use the red one. No even roots of negative values, e.g. the cube root of minus whatever, the square root and the fourth root of whatever, and the sixth root of whatever. This does not exist, guys. It will just give you a math error. Okay, so this has to be noted as well. Okay, guys, I chose it deliberately because of I just wanted to show you this. Now let us try again a -1. So let us try another one. But then no, let me leave it, guys. But then should I try it? No, let me just leave it, guys. I just wanted to keep this video short, so I think I can just leave this one, right? Do you guys allow me to leave this one? Let me just leave this one. Let me just give you an exercise based on these things that we have done. Okay, let me just give you the exercise, guys. Thank you. Just screenshot this exercise, the following exercise, and then you will complete it after you have watched this video. If you didn't watch this video and you didn't understand, guys, you will struggle to answer those things. Okay, so make sure that you watch this video and you understand each and every fiber of it.